Hello everyone. Today we are going to talk about electric potential energy and electric potential. And we're going to find the relationship between them, and we're going to look in this subject as a whole. How did we get here? Okay, so first of all, we learned about electric charges. If there's a charge here Q1 and another charge here Q2, and there's a distance between these two charges, let's say this is distance r, we found out that there is a force, we called it Coulomb force, and this Coulomb force is equal to K Q1 times Q2 divided by the distance between them squared. Okay? Then from there, we also learned something about, we called it electric field. Electric field basically is the force on one charge from the electric field coming from another charge or from any other sources. So if there is a positive test charge, we called it Q0, and there's an electric field on it like that, this charge will feel the force of the electric field or will feel the effect of the electric field. We called the electric field due to a point charge K Q over R squared. Now notice the difference between this one equation and this one equation. This equation for the force has two charges because it's the charge between two forces. This equation for the electric field has only one point charge because that's what the electric field will feel. Okay? Also we should know that these two quantities, the force and the electric field, are both what? Vector quantities. And the force is measured in Newton, so that's the measurement of force. And this is, since it's force over Coulomb, it should be Newton per Coulomb. So this is, now, today we are going to talk about something related to the electric field, which is the electric potential. But before that, we need to mention something about the electric potential energy. Now, why are we learning about all of this? So what's the big picture about this? I'll tell you. We have force between two charges, an electric field. Electric field, we will see that it has a relationship to the electric potential energy, and the electric potential energy has a relationship to the electric potential. And why do you care about that? I'll tell you. Because the electric potential, this little guy here, that you may not sure what it is just this guy. Do you know what this is? What is this? Yes, this is the battery. That's the battery. The battery actually is an electric potential. It moves, it's like an engine that pushes the charges from one side to another. And that movement of the charge is creating current, and current is necessary for the light, for the computer, for everything that you need in your daily life. So it is really important about this that we need to learn the potential. Okay? The electric potential, that is. Okay. Well, the question comes, how do we learn about the electric potential? We have first to learn about the electric potential energy. Okay, let me remind you. Suppose that this is the nice little Earth here, and you have a ball with mass m, and you lifted the ball up above the ground by a distance h. Then the ball is let go, so it's dropped. So basically the ball is going to come down like this. It's going to accelerate due to what? The gravitational field of Earth. So the ball as a mass felt the gravitational field of Earth, and it actually moved from a higher potential point. So I'm going to call this 1, I'm going to call this 2. So maybe I should call this gravitational potential energy. Since it's point 1, I'm going to call it 1. And this point here is the gravitational potential energy, and this is 2. So GPE1 is bigger than GPE2. Okay, GPE1 is bigger than GPE2, and thus the mass moved from point 1 to point 2. And from there we found the work from point 1 to point 2 is equal to basically GPE1 minus GPE2 and so forth. That's what we did in the past. We needed this example just to understand how that is related, or maybe as a demo, to what's coming in the electric potential energy. Well, how do we translate this gravity into the electric potential energy if we're going to look at it so that we can relate the two things together? Okay, the best thing is to create an electric field, and the best way to create a uniform electric field, that is what? By a capacitor. So let's say we have a capacitor and it's charged. As you know, the electric field goes from the positive to the negative and so forth. If you bring in a positive test charge, we call it Q0, and we put it at point, I'm going to say put it at point 1. What do you think is going to happen to this charge once you release it? Remember, we were talking about the gravitational potential energy. We have an object with mass m. What happens to it when you release it? It's going to go. The same thing, it's going to go down. The same thing here applies to a charge. This is a positive test charge. Once you release it inside a uniform electric field, it's going to move from position 1 all the way down to the other side. But let's look at it at another time, another position. I'm going to call it 2. All right? So basically, the charge will move in this direction. We are going to call this point here electrical potential energy, or electric potential energy. Just like we call this gravitational potential energy, this is electric potential energy. And this is your first acquaintance with the electric potential energy. What does it mean? Okay? Just to relate to it, try to understand this first. Okay? So this is, I'm going to say electric potential energy. Since it's happening at point 1, I'm going to call it point 1. And this guy here is the electric potential energy at point 2. Since the object, or the charged object, moved from 1 to 2, this means that the electric potential energy at 1 is higher than the electric potential energy at 2. So this is actually what we are all talking about here. Okay? Good. And that's it for this quick introduction about electric potential energy. Thank you.